All right, Tyler, can you hear me? Tyler can hear me now. Can we turn the volume up maybe a little bit? That sounds good. Good afternoon, everyone. Welcome to ITS Georgia's February monthly meeting. Glad to see everyone here. For those of you still in line waiting to get food, please feel free to take your time. I'm going to be right behind you. And thank you to Mary and Emily and Kate for getting all this lined up for us. It looks very wonderful. Before we go too far, I actually want to hand it right off to our sponsor, Kimley Horn. So Juan, I'm going to have you come on up and say some kind words about Kimley Horn before diving into the rest of the agenda.
All right. Thank you, Matt. All right, so for those of you that don't know me, my name is Juan Duarte. I have been with Kimley Horn about over 10 years, I think. And well, it has been a blast. We have a big group of people. Our company has been growing over the years. Since I joined, I think that our traffic and transportation group was about, 20 plus people. Today we are close to 60 people. And just to give you an overview of our company, we have about 7,500 employees nationwide, probably over 120 offices. And well, we do all kinds of things. In the civil engineering side of things, of course, we are on the traffic and transportation. As most of you know, we do a lot of ITS, fiber design. We also do roadway design, bridge, structures. And but there is a lot of other fields that probably several of you don't know. We are on the aviation side. We are on the energy services. We do a lot of technology solutions. We are helping developing apps that help, finding EV charging stations through the area. And we have parking solutions. We have pavement assessment. So there is a lot of things that we are doing. And I encourage you to go to our website or talk to any of us that are here, which I'm seeing a lot of people here. And I think that we have, it seems like all the front row is Kimley Horn, so, and some in the back row. So. I don't know if all the Kimley Horn people can stand up or raise your hand just to show how many of our traffic and transportation groups are here, and maybe we can do the wave. And but yeah, I'm glad to be part of this project. I know that we help Alex in this runway project, and very excited about this presentation. And anything that you guys need from our team, just let us know. That's it. Thank you.
Appreciate that, Juan, and thank you again to Kimley Horn for sponsoring. You know, what makes these monthly meetings possible is through y'all's kind contributions, specifically Ken Fink's. We knew this come out of his credit card. So again, welcome to our second monthly meeting. Our topic today will be from GDOT with their new wrong way driving program. We'll be hearing from Alex Estrada and Bill Gunter here in a few moments. And as I said, my name is Matt Glasser. You have traded down from Kimley Horn to me as your ITS Georgia president. So sorry, you'll be stuck with me for 2 more years. But with that, I'm going to do some jumping between some of our really great volunteers. And again, we can't make ITS Georgia president without our wonderful board and the volunteers that help support them. So first up, I'd like to hand this off to Troy Galloway to talk about our annual membership renewals, which are open right now.
Hey, everybody. So currently we're sitting at 43 members. So this will be the last monthly meeting that you will get the monthly rate from last year if you're members. So I think there was 86 members last year. So we're going to be cleaning up that roll in a couple weeks. So we have the QR code up there. So you can use that QR code and sign up. I will be sending out a blast this week to everyone that was a member last year. If you haven't registered, if you're a vendor and you haven't been a member or a technology provider and you're planning on doing any exhibiting at the annual meeting, you pretty much save $400 for signing up. So it pretty much pays for your membership just with that. So if you're interested in joining, that's a good way of saving money as well.
Appreciate it. And if you have any questions for Troy, he has his own dedicated email address, like most of us, but a secondary one, which is membership at ITS Georgia, and that's itsga.org.
And if you need an invoice, there's a link on there that sends me an email. So if you're an organization that needs an invoice, I'll get an email
Thank you, Troy. Next up, just want to do another shout out for Whitney Nottage, who is not able to be with us here in person, but she and the communications team have been working very hard over the last year to stand up a brand new ITS Georgia website. If you haven't been there yet, please check it out. It's a lot more responsive, a lot more snappy looking. Got all kinds of wonderful things on there. And most recently, our new and updated ITS Georgia bylaws have been posted for your review and constant comments. Next up, I'm going to hand it off to Tom, who has a mouthful of food, to talk about volunteers, elections, and awards.
Thank you, Matt. So like every professional organization, our lifeblood is your money and your young staff. So we're always looking for volunteers to help support the organization. So if you're interested in volunteering for any of our committees or subcommittees or to participate in the annual meeting, please reach out to Matt at president@itsga.org, or you can reach out to me at pastpresident@itsga.org. Just as a reminder, we talked about this briefly last meeting, but with the new bylaws for nominations for board of director or for the eligibility for board of director positions,
which aims to create community development districts that could be used to finance, construct, acquire, operate, and maintain public infrastructure for residential developments within the boundaries of the CDD. So that's pretty much all the activity that's going on at the Capitol Dome. And to Tom's point earlier, since I'm already up here, I just wanted to quickly talk about outreach. And the month of March is just chock full of volunteer opportunities that have a STEM focus. So if any of you are interested in participating in ITS Georgia, perhaps as a board member or doing more volunteer work, this is a great way to get involved with the organization, be a part of other volunteers like me. I got roped into doing a whole bunch of volunteering next week. So if you're interested in being a part of Introduce a Girl to Engineering, there's some other local programs that are happening here that also have a technology and STEM focus. The Technology Student Association is going to have events happening March 13 and 14, and I'm going to be volunteering quite a bit for those. So if you're interested in being a part of any of these events, and there's a ton of them, feel free to come see me after today's event, and I can give you my contact information. So thank you very much.
Thank you, Stephen. Next up is Madison Dormany from AECOM talking about some the annual meeting and our social events that are coming up.
Hey y'all, is this still on? Yes. So our first thing that I want to talk about is we have a social event tomorrow night. We're going bowling in Alpharetta at main event starting at 5 o'clock. So hopefully I'll see a lot of you there. If you want to shoot me an email and let me know you're coming, that would be helpful too. Then we're also going to do March Madness this year. It was very popular last year. I'm looking at Gunter, who had some success at March Madness last year. Yeah. So we'll do that again this year. Then on the annual meeting side, September 15th through 17th in North Augusta, the Crown Plaza. The theme this year is going to be Mastering ITS as kind of a play on being in Augusta where the Masters are held. So go ahead and save the date for that. The call for sponsorship is going to go out soon, and then registration will probably go live sometime in May. Thanks.
Thank you very much. And last thing before we get our monthly speakers up here is just a heads up that next month we will be down at One Georgia Center to hear from Meg Perkle. And in April, we haven't quite settled on the speaker yet, but we will be at Monday Night Garage, which is in Westside, Atlanta. Both of those are the fourth Wednesday of the month. Is there something that you'd like to add, Emily? Thank you, Emily. Yes, we expect that one to hit capacity. So to echo Emily's comment, please make sure to sign up early. And with that, let me go ahead and introduce our speakers. We have two today. Alexander Estrada is currently serving as a state ITS engineer for the Georgia Department of Transportation, where he plays a key role in overseeing GDOT's ITS program. Alex began his career at the Florida Department of Transportation and has a background in his highway design, project development, concept development, traffic operations, and leading interdisciplinary design and planning projects. In 2021, Alex joined GDOT's ITS group in the Office of Traffic Operations, further expanding his knowledge and versatility to effectively tackle the ever-evolving challenges in the transportation sector. Alex is a graduate of Florida International University, where he earned both Bachelor and Master of Science in Civil Engineering. He is a registered PE in both the states of Georgia and Florida. Additionally, we have Bill Gunter, who is an area manager with BBH, now in his 15th year with the company. I did not know that. He runs the Marietta office and serves as project executive on several large design build projects, as well as the GDOT statewide ITS maintenance project. Since entering the industry in 2003, he's worked on many of the notable transportation projects in the state and has stories about all of them. With that, Alex, Bill, come on up.
Well, thank you for joining us today. Thanks, Matt, for that beautiful speech. So today we're going to talk about the runway driving pilot system that we have implemented at GDOT. Currently, it is located at two locations, and we're going to kind of briefly talk about the kind of the overview of the system, how we got there, and then Bill is going to actually talk more about the installation and some of the challenges that we've encountered with our unique system. As we know, runway driving incidents are usually severe in nature. However, they're very infrequent. But when they happen, they tend to make the news. So there could be high-profile type of crashes that we see out there, especially limited access right away where the speed is a contributing factor. So something that's unique about the runway driving crashes is this is one of the few type of crash that the actual location of the crash may not reveal the full story, right? As aside for other type of crashes where you can take a look at maybe a hotspot type of diagram and determine if that specific location has an issue. However, with runway driving, a vehicle can enter into the system and continue on for several miles until there's an incident. So when looking at the runway, specifically runway driving crashes, we tend to use other type of methods to analyze it. And luckily we had some data from Estrada that tracks runway driving through the toll points. So what we did is we looked at the graph on the left shows the northwest corridor, and on the right is the south managed lanes. And each of those toll points were collecting some runway vehicle data. And so what we did is we chose the top two for each corridor to test out our system. And that is how we kind of selected those two areas to implement it. So as you can see here, our system right now, we have basically there's two systems on Terra Mill Road, which is a south and north ramp, and TP3, which is toll point 3, it's a Jonesboro Road, which is on the south managed lanes. We have one system there because it's a single entry point into the system. And the way the typical configuration works, usually it varies by manufacturers, but typically you have several different type of activation zones or detection zones. So the first zone, what you see out there is, I would call it more of like the detection zone. And then as like a vehicle enters the system, there's additional zones where you want to confirm that a runway driving incident is occurring. But those incidents can happen so fast that those two zones get crossed by a vehicle very quickly. And there's different type of technology that could be used for detection. Right now we're using thermal for both of those locations. But radar also can be used, and additionally, as well as probably video, depending on the type of system we are implementing. This is just a little snippet of how the thermal imaging looks for the detection system. And this is a typical configuration. It could be used with both solar or AC powered. We actually have both installed. Some of our signs and the flashers are actually on solar on Northwest Corridor, and the actual cabinet and the detectors are on AC power. And on Jonesboro, we all of our things are on the AC power. But with this configuration, we were not able to use this specific type of sign where it's always lit up as runway, because due to the nature of being reversible lanes, we had to come up with a more unique approach to it. As you know, we didn't want to tell vehicles that they're going the wrong way when certain times of day they actually going the right way. So we had several solutions for it, and what we installed there was an actual like a blank out type of sign where it only lights up when the lanes are reversed and they're actually going the wrong way, and it's tied back into our express lane warning gate and barrier gate system. And with that, I'm gonna let Bill kind of take over and talk more detail about what we've encountered in the field.
All right, thank you, Alex. Good afternoon, everybody. Good to see everybody again. See if I can figure out the hardware here. Alex has kind of explained why the system was deployed and how the locations were picked. So I'm going to kind of talk a little bit about how we actually implemented it, and then I'll hand it back over to Alex to give you an overview of how it's been working so far. So basically, the implementation was just about as interesting as the technology was itself and the whole scenario that led up to deploying this system. So just a few things we're going to talk about related to that. It was a very collaborative approach. Obviously, we had GDOT, that's their roadway and their system to deploy. They actually had purchased this system prior to us installing it. So conventionally, we get a job and then we buy the equipment based on what the specs say, and then we deploy it. But GDOT had already gone out and bought the equipment. So had obviously GDOT on board for several of those reasons. And then we had the vendor, so Tapco and Utilicom, and I'll name drop here, so you can, if you got any more detailed questions for the experts, you can ask them. They sold the system as a Tapco system, and then obviously they were on a purchase order through GDOT, and then we had Atkins on the design. Hannah's here, and we'll talk more about her efforts on that. They were on a contract with GDOT as well to do some design for us, and then obviously. Us, the lowly contractor, was just here to to put it in and then get all the styrofoam cups thrown at us by all the angry drivers driving by. And obviously, we're under the ITS maintenance contract, so this was implemented and deployed under that contract. I'm going to talk a little bit about the benefits of having a design. So kind of rewind about a year and a half back and think about what the world looked like in 2022 with everything going on, a lot of people virtual. More so than now. So we had all these people that I just mentioned spread out all over Georgia and the country, and we're trying to figure out how we're going to deploy this system. So much of this was done virtually and remotely. We never got to, all of us were actually, to this day, I think today may be the first time we're actually all physically in the same room together, everybody that was involved in the system, minus my guys that are out there in the rain, so, shout out to them. I'll be out there soon. But not having everybody in the room, obviously, how do you coordinate that? And I was talking with some of you earlier about coordination and communication and how big of a deal that is these days with everybody kind of being dispersed and not being in the same place. So that's where the design came in. So even though it was not an elaborate project, we're not talking hundreds of plan sheets or something like that, or doing a lot of permitting or anything like that. Having a set of plans just to work off of, so that when we shared a screen, we weren't just having to go to Google Earth and saying, oh, do you guys have the same place mark as us, so on and so forth. So being able to work off that same sheet of paper was tremendous. And that was a great, I think, great credit to GDOT for bringing them on board and having that as a tool for us. And then lastly, installation challenges. And the locations that these were installed at, we're going to go through some pictures here, and that's mainly what I'm going to talk about is just the challenges. But these were not the easiest locations to work at for a variety of reasons. So a little bit about the design. So this is basically just an example sheet of Terrell Mill. So as you can see, we had something we could work off of. I've got many copies of these with notes drawn all over it about how we're going to do this, how we're going to, where we're going to put things. And that basically allowed all of us to work off the same sheet of paper. And then when the guys went out there to install it, everybody knew what they were doing. Because like I said, this is not a construction project. This was a implementation and integration of technology, and a lot of times it's how do you put technology on paper so everybody understands what they need to be doing and whose role they play. So having this was a great tool and a great starting point. Some of the challenges of installation. So this is the Terrell Mill north ramp, depending on time of day, but it's on the north side of Terrell Mill. So as you can see, there is a lot of limited real estate on this. That's kind of a contradiction. There was limited real estate. There was not a lot of real estate to deal with here. We had some soil nail walls on the left. Obviously, we can't do anything with those. MSE walls on the right, barrier wall, concrete shoulder, concrete roadway paving. And those of you that may not be familiar with Terrell Mill, 6 inches underneath Terrell Mill is solid rock of the hardest Georgia granite you'll have ever come across. It's I think Stone Mountain kind of goes underground and then surfaces a little bit at Terrell Mill. So there's no way you're going to be putting in foundations for poles without destroying a lot of express lane infrastructure, which could not be done. This was a live ramp. These lanes opened in 2017, 2018, if I remember correctly. And they operate every day, and midday they reverse directions. So we can't just shut down the ramp. There's revenue implications for that, and also safety implications to that as well. So express lane coordination was pretty big too, working with TMC operations floor, which they were a great partner in all this, making this work where we were able to work around their schedules and not impact operations at all. So the installation, getting down to the kind of the nuts and bolts of what we did here. So on the right, there's a picture. Those are the sensors, and I won't get too much into that. But basically, the two on the right, kind of in the shadows, are the thermal sensors, and the two kind of center and left are the conventional fixed cameras that will, record what happens when it detects something. So solutions, obviously we had limited real estate, so what do? We can't put in these big pole foundations, so we got with the Office of Bridge Design and worked with Don and his team to come up with mounting solutions for this system that were custom designed for this system, but were acceptable to the bridge office as far as we're obviously not going to do anything. We're not going to impact bridges, Terrell Mill Bridge. We're not going to attach stuff to walls. We're not going to bore, behind walls and cause all kinds of issues. So we were able to come up with a really good solution, working with them on something that they accepted as far as being structurally sound, but also didn't cause undue commotion and impacts to the existing infrastructure. As Alex had alluded to, there's a solar and wireless architecture used for this. So Terrell Mill has a lot more what I call the real estate issues than Jonesboro Road did. So Terrell Mill, we had to use complete wireless and solar system for the warning signs and the flashers, because there was no way to run conduit to those locations. And then the trigger that actually tells the system when to turn on is also wireless. So it's tied in. Instead of going and trying to add a new module to the reversible lane system, what we did was we tied basically a sensor into one of the gates. And when the gate is either open or closed, it's sending a signal back to the wrong way system to tell it what to do. obviously, if the gate is down, that's a pretty safe way to say that the ramp is closed when it's open. So tying into that, there was no software modifications or any additional hardware other than that sensor. And then obviously we worked around the express lane schedules. So we worked on one half of the ramp in the morning, and then when they did the reversal, we worked on the other half of the ramp in the afternoon, and just kind of flip-flop back and forth, and it worked out really well. We'll talk a little bit more about how we did it when we did the turn-on and the calibration, which was a pretty interesting experience as well. So picture Terrell Mill. So if you see that camera pole at the top of the picture there, and I might walk around here a little bit. But as I was saying, where we used existing infrastructure, we've got a existing GDOT camera pole here and a cabinet that had GDOT network in it. So we were able to tie in and mount the wrong way cabinet there. And it's basically wirelessly down. The other ramp is on this off to the right of the picture here. So, besides running that conduit up the pole, it was there's not a lot of other stuff to have to do, and kept the pole clutter down, and still had good line of sights for everything. Again, more of that. Try to use what's there instead of just adding more just for the sake of adding more, because there's lots of places we drive around to. It's like, why are there 6 poles here when there could have been 2, kind of thing. So. Here's a picture, kind of a before and after of the, and I'll come over here to kind of point this out too. This is a before and after. So obviously this shows the limited clearance between this soil nail wall and the barrier wall that we're mounting on. So conventional square, like wrong way signs that was in the graphic earlier, we're not going to fit here because you can't cantilever it out to the right. So you're like, well, let's take the square and let's just shift it on the pole. Well, then it's hanging over the road here, and as tractor trailers do, even though they're not supposed to be on the lanes, they'll pull over here and inevitably knock this sign off the pole. So worked with the vendor to come up with this vertical sign. So it says wrong way, but it's vertical. The flashers just barely fit, and then you got solar panel just popping right up over the wall to get good view of the sunlight. So that was a good solution there. And again, like you see, there's no demolition of the barrier wall required. Talk about this a little bit later, but we also tried to use the kind of what quote unquote catalog material. So if something happened, somebody at GDOT, we could call up a vendor and say, hey, I need another one of these instead of having to get custom designed. So these poles right here are actually the variable speed limit system poles, which is a standard catalog pole. So kind of a fun fact there. On the other side of Terrell Mill, so this is because they're not paying attention to it. So I think a great use of technology there. The picture on the right, that's the kind of the sensor array at Jonesboro Road, and you can see the flashers and the blank out sign there. And let me tell you, these flashers are very bright. There can be no argument made that you did not see these things, because we aim them to shine right in your eyes, and they are bright. So they're very effective warning for the ramps, and the ramps are lit as well. So visibility is pretty good there. And then just one last thing before I hand it back over to Alex. So as I was talking earlier, the implementation, the integration, the testing of this was pretty interesting, because obviously we had to test these by running a vehicle the wrong way up a ramp. Well, how do you do that? We were thinking about doing a 12-hour express lane shutdown, but then that would be at night. There were safety issues with doing this at night. The cameras are thermal, the sensors are thermal, so it didn't really matter as far as that goes. So what we did is we got off-duty police officers, and we shut the ramps down during the reversal. So we had about an hour and a half on both systems in the middle of the day. And as soon as Hero came through and closed the ramp down, we blocked it off for safety issues. And also, we didn't want a wrong way incident to happen while we were testing a wrong way system, unless it was us that was doing it. So shut the ramps down, ran the test vehicles through there, calibrated everything, and we're in and out of there, within an hour and a half. We've come back a few times to do PMs on it. We do it the same way. Pretty good process. And again, a big part of it was zero or little impact to operations. So again, we didn't have to tear the ramps up. We weren't out there for months with temporary barrier wall up. And then even when we did something like testing, we were low impact. And really, a primary point of that low impact is not causing a situation that motorists are not used to, because obviously there's already an issue here with motorists not doing the right thing. And second of all, just keeping our guys safe, because anytime we're out on the road, we can be behind an 8-foot barrier wall and somebody will find a way to come hit us, unfortunately. So it's just part of it. So anything we can do to increase safety is definitely considered top priority. And then just one last picture of the system. This is kind of looking back up to the north here, and you can see the signs on both sides of the ramp there. And again, this kind of picture just represents kind of the distance you've got. Where this picture was taken is not even at the beginning of the ramp, so you can see you've got plenty of visibility of it. And again, zero mess. It looks like we just came in one day and just stuck the poles in, and you ask the general public and they think, oh, that took like 15 minutes. Well, the hundreds of hours that went into it of all of us working to implement something like this. And with that being said, we'll take questions at the end if you got any, but I'll turn it over back to Alex and let him talk about what we did once we got it installed.
Thank you for that, Bill. So as Bill was saying, we went through the testing phase, and Bill had a little bit too much fun. That's him driving the truck up the wrong way several times. I couldn't use all the videos because they might be a little bit too fast, but I think you did a good job there driving. We had a lot of fun driving up and down. I think Emily also was driving a GDOT vehicle at the time up the wrong way, but it all went well. We were able to calibrate it, the system, and it worked fine. So here's some of the results after we've installed it, right? Because we had all this data from the Estrada to see what was going on, but it was kind of nice to see what actually is going on. So as you can see here, we have the warning gate down. It says do not enter, meaning this is the south ramp. So that means right now the express lanes are going northbound, and this vehicle is going right now southbound into the system. So as we were saying, we have this zone which is more of a detection zone, and as they proceed through the zone, the next one would be the actual confirmation that they continued on. And as you'll see between these two, you'll see those, it's a little hard to see, but at the end you can see those red signs light up, and the vehicle actually stopped, and they were able to get out of the express lanes without going all the way up. So that is definitely great to see where you know the system that you installed is doing its job, and we're able to prevent somebody going up the ramp. So here's some preliminary results. This is for that south ramp for Terminal Road. Basically, over 50% of vehicles that we saw, they've self-corrected, meaning they went the wrong way, they saw the signs up, and then they were able to either back out or turn around. There's also we put, as Bill was saying during the design, right? We kind of moved from the original design, had the signs a little bit closer. However, we thought it would be good to have them further away. Also, to let give some space to the driver to turn around, and also you'll be able to capture them further up the ramp. So I think that worked out pretty well, and they were able to, we were able to avoid some people entering the express lanes. And for terminals, it was interesting. I know we saw a lot of runway driving statistics from Estrada, where that ramp was a kind of like a hotspot for self-managed lanes. However, from reviewing the data that we got, it is looking like majority of those vehicles are actually maintenance and law enforcement. So those are authorized vehicles that are able to get into the, it's happening during the reversals most of the time. So, that kind of tells us that there might be not as big of an issue on that ramp, but however, we want to further expand the system to implement additional detection further up the ramp, especially for the main line, to have that additional confirmation. And right now we're working with Kimley Horn on developing a design for the additional ramps that we have, mostly on the northwest corridor. But we're also looking back at the Terramil and the Jonesboro to additionally have some expansion there for mainly for the main line, just for us to know if the vehicle actually made it to the express lane, because that's going to help us, our TMC staff, know how best to respond to those incidents when they happen. And with that, we'll take any questions.
Just saying, questions, make sure you say it to the mic so that way we can capture what's being said.
Great presentation. Looks like you got good results. I'm wondering if you had any numbers or stats on missed calls or false calls on the system.
Well, from the data I've seen, they've been pretty reliable, like the ones I've reviewed. We definitely have seen some pedestrians as well, bicyclists. Like you'll see some things that get triggered, but they're not a runway vehicle. So I wouldn't consider those false calls. So I don't think with such a small system, we still haven't seen I think the broad spectrum. Once we have more of the system laid out, I think we'll see maybe there's some adjustment that need to be made. But I think for these two, I haven't seen like too many false calls for that.
What's the lag time on the thermal notification versus the actuation of the signal?
It's pretty fast. It's like, I don't know if Bill, you have it.
Yeah, I mean it's so there is a delay, but it's very, very short. I think TAPCO might be able. Yeah.
12 milliseconds.
Yeah.
Second question, non-engineering related. Has the Georgia State Patrol been shown any interest in LPR cameras to capture a citation opportunity?
Don't know, not a trooper.
Sorry. How many are you planning to do throughout the state?
Well, right now we're focusing on the managed lanes, right? Northwest corridor and south managed lanes. So there are a few. Most of them are northwest corridor, just based on that runway vehicle data that we have. So that's gonna be our next focus. It's it's not as many right now. Probably like 4 or 5 more spots on the managed lanes. That's our focus right now. And then I can see in the future we might expand it beyond just the managed lanes to see it on other locations on the limited access right away.
I'll kind of follow up on that. Is your experience here, how is that informing future designs, both for managed lanes and for limited access?
You want to touch on that one?
Yeah. If Tom, you talking more like a policy decision or more how we would implement it kind of thing?
Either.
From a, I'll speak from the implementation side, and and I'll give my 2 cents about policy because why not? But from the implementation side, yes, we have learned some lessons, both how this specific hardware works, how hardware like this in general works, and then just the coordination involved. I think one of the big lessons that we learned that would take forward if we were involved in something like this again would be the signs, either the blank out or the non-blank out signs, obviously because we're doing reversible, and then how we would activate that system. So if it were not on a reversible ramp, the implementation would be a little bit different as far as where it's triggering, where it needs to notify, and then what happens to the notification after that. Especially since on this system we've got SERTA toll points, which provide a secondary level of confirmation that something has happened. And it's also, there's a distance between there that can say, if you get the wrong way detection from this system, but you don't get it through SERTA's system, then obviously they've made a U-turn. So things like that as far as implementation, but then just generally lessons learned for deploying something like this. And I think one of the big ones is trying to do this with the least amount of impact possible, kind of like we did here, where you're not spending unnecessary amounts of money to put in all this infrastructure when it can be really done as a retrofit application. I'll let kind of Alex, if you want anything about it.
Yeah, and we're working with our safety office as well. Right now I'm representing the ITS solutions. However, the safety office does have some initiatives or runway countermeasures for runway driving. So that's definitely something the department is looking at.
Alex, you may have just answered this. I was wondering if there was notification to the TMC when they get a wrong way notification to be able to alert law enforcement, because having dealt with this before, they're never out there in time. That's for sure. Yeah,
that's a really good question. Right now, the TMC does get alerts through our operators. However, the system is not fully integrated into our ATMS, and that is something that we're looking for future deployment, where once we have our new ATMS in place, our goal is to actually have them integrated into the fully into our ATMS system. That way it's easier for operators to make those decisions, whether to send law enforcement, notify the right parties, right? And alert the other drivers, right? That's gonna be the goal. Currently, we are getting, you can sign up either text, email, or go into the login into the BlinkLink system that's from TAPCO that we have. And that's what the operators are using right now to kind of confirm what incident happened. However, we are looking into further expanding that into actually our ultimate goal would be integrating all that into one ATMS system where you're able to get alerts and respond appropriately.
If anyone else has any questions, give it. Oh, did I miss somebody? Oh. Never mind. Oh, there you go.
What are you guys estimating for a cost per rollout, per location? What's an acceptable cost? What's the cost at right now? Like, where is it reproducible?
Well, since we don't have like a, GDOT doesn't have a pay item for it, or a spec, it's hard to say what the cost is. But I've looked at other states that have specifications. They have a pay item for the system, and it ranges anywhere from 30,000 to 70,000 per location. That's kind of the ballpark cost of the systems like that is.
I think that does it for questions. Want to give a hand to our speakers today. Thank you, Alex. Thank you, Bill. Very much appreciate you guys coming out. Thank you all for coming out. Drive safe. I think, is it raining? If it is raining, drive safe, drive slow. Make sure that you are not texting and driving. Make sure that you are doing hands-free. And again, remember, registration will be coming out in a couple days for our March meeting. If you do not register early, you may not get a spot, so be diligent. And for those of you that have not signed up for ITS Georgia's membership this year, please make sure to do so. Thank you.